The chapter opens up with the example of how the overpopulation of geese can cause many problems with the traffic, especially within planes. Geese sometimes get inside the plane's engines and causes the engines to crash. So they could wait until migrations for the birds happen, but it doesn't happen all at once. Migration for birds is a process. They have to fly hundreds of miles and make sure that the place that they have chosen has enough resources for them and possibly their young. So now they have to figure out a way to control the population without harming the geese. So researchers study their ecology, which is how they interact with species that are alike them, that are their species and different species. But before they can determine their ecology, they have to take population into consideration, which is kind of when demographics come in place. So demographic basically helps determine things about the species, such as the population size. So gathering all of the geese one by one would be kind of hard to do. So they go through a process called plot sampling, which estimates the number of individuals that go through a process, and they go through a process of capturing, marking, and releasing animals. And over time, they capture them again, and this way they can determine different characteristics between different species. Okay, and this is just a picture of the Canada geese. They tend to be plant-eating birds. They reside in golf courses or any place where there is a lot of grass or a lot of plants. Animals don't always live close together. Resources and such as habitat and food don't allow them to always. If it's scarce, then they will live in random distribution, which is more common in like deer. They need their own space to eat, to live, or they will live in natural and never uniform distribution, which is limited resources but they are evenly spaced out amongst each other. Unlike clump distribution. Clump distribution is when the species as a whole or the population as a whole is used to being together. They all eat together. They live around the same proximity of each other with no problem because the resources that are available for them to do so. Population size and exponential growth. Immigration is the arrival of new residents. This can impact the population of a species by birth, which means that since there are more animals or more species coming into a certain environment, it will increase the number of its members. Immigration is when individuals leave who are permanent residents. In many species, the young, either male, female, or both, tend to leave so that they can breed somewhere else, so they can have their own habitat, their own resources that they need in order to population size and exponential growth. Immigration is when the arrival of new residents come about, and this can impact the population of species by birth, which means if a new species come into an environment, it increases the population because they are breeding, and the people who were already there, or the species that were already there, are breeding, so the population increases. Immigration is when individuals leave who were permanent residents, like the youth in some species. Either the male, female, or both of the sexes leave from where they were born to breed somewhere else. Maybe possibly it could be because of resources such as food or habitat. And this is when zero population growth comes into the picture. It determines if the births will balance out with the number of deaths. They measure the birth by per capita growth rate. And the formula for that is B, which is per capita birth rate, minus D, which is per capita death rate, and it equals R, and that gives you the per capita growth rate. Limits on population growth. While the population of many species, even humans, is continuing to grow, density-dependent limiting factors cause birth rates to slow and death rates to rise. Some factors that contribute to this are competition, predation, parasitism, and disease. When resources are limited, it may cause species or individuals within a species to compete, even amongst those, that are in the same species. When the population as a whole over time is affected by density dependent factors, logistic growth happens. Okay, the chart that represents logistic growth is a S shape. And the equation is G, population growth per unit time equals R, maximum per capita population growth times N, number of individuals times K minus N, K, the proportions of resources not yet used. Natural disasters do happen, but it can change the population size drastically. So this is called density independent factors, and it's because crowding does not influence or change the effect of this. Life history patterns. A cohort is a way to describe life history patterns. Life history patterns. A cohort is a way to describe life history patterns. Life history patterns. To tell when an individual. Life history patterns. Ecologists, when they do their research, they often divide populations into groups by their age or classes. But they use a cohort. A cohort is a trait that tells when individuals are born during or around the same time. The data that is collected determines how changes can alter and change individual environment. The chart that is used to explain all of this is a survivorship curve. It's basically a chart that shows how many members of the cohort are still living. Okay. Effects of predation on life history. Guppies are used as an example for this topic in the effects of predation on life history. Guppies are used as an example. It shows that when put in different living conditions, it can alter their size, such as when a stream has a waterfall in it, it will keep their predator from moving to the other side of the stream. So the predators that are in that portion of the stream that they can't move to will strictly survive on guppies that are the same size that they are used to. For instance, if the small predators of guppies, such as killifish, go for smaller guppies, they ignore the larger ones. So guppies over time adjust to this, which means they will maybe produce larger guppies. So the guppies as a whole, or their population as a whole, can grow more. Humans do take part in this. For instance, when people will overfish the Atlantic cod, it causes the cod to reproduce at a younger age. And reproducing at a younger age made them have babies that were smaller. Human population growth. Humans in the beginning did not produce as rapidly as they did now. It didn't increase until about 10,000 years ago. But as humans, we are constantly evolving. Things that contribute to the growth of humans is new habitats, development, and technology, and they overcame factors that restrain population growth. As humans, we evolve not only physically but mentally. So the more that the mind or the brain evolves or grows, the more knowledge humans obtain. So when they obtain more, it means they are able to master skills on how to survive and maintain. This causing the population to grow. People who knew more would go out into new environments and try to maintain and live there. So things like fire and clothing gave humans room to migrate just about anywhere that they wanted to. And when agriculture was created, it gave them chemical fertilizers to make the crops grow more rapidly, and they would have food to survive on. As humans, the population size will continue to grow. And these are just a few vital terms that I talked about that will come in handy when studying the population ecology.